We're going to take a look at the concept of graphing inequalities, and it's going to be very similar to graphing equations of lines from before. You might recognize two famous methods for graphing these equations of lines. And we're going to follow these three steps here, and I'm going to put these back at the end of the video or during the video to show you what's going on. But we're going to graph the equation, and I say equation in quotes because we're going to have not an equal sign but an inequality sign. But we're going to graph the inequality just like it was an equation, just like before. And then after we do that, we're going to have to make a decision about whether we want a solid or a dotted line. That's going to be a very easy decision. And then we're going to end up shading to one side of a line. And these steps right now may not make any sense, but by the time we go through two examples, they're going to make a lot of sense, and it's going to be pretty darn easy. So here's our first example, and when you look at this, your brain might be thinking, hey, y equals negative 2/3 x plus 4, and I've put an equal sign there. These are called inequalities, what we're doing here, because simply instead of having an equal sign, you have an inequality sign. Well, when I look at y equals negative 2/3 x plus 4, or when I look at this one, I think of y equals mx plus b, and that tells me this is in slope-intercept form, and in fact, I already have my y-intercept. When it's in this form, solve for y, you've got your y-intercept is 4. Put a dot there. All right, and now you've got the slope, negative 2/3. The negative tells me my line is heading downhill, and this is the rise over the run. So I can count negative 2, right 3, negative 2, right 3, and I can keep doing that. Negative 2, right 3. Or I could have done a positive 2, negative 3, and put a dot, and that would stay on that trend. So remember, when my slope is negative 2/3, I can think of that as a negative 2 over 3 or a 2 over negative 3. They're both going to give me the same thing. So at this point, if we were doing regular old equations, I would draw a line. We have completed this first step in graphing inequalities, which is graph the equation. We chose the y equals mx plus b method because it was already set up like that. But in our checklist, the next thing we need to do is determine if we're going to have a solid line or a dotted line. And that's going to be really simple. You're going to look at the inequality sign in the problem. And if the inequality sign has an equals underneath, we're going to go with a solid line. If it doesn't have any equals underneath, we go with a dotted line. If you wanted just a tricky, silly way to memorize that, it takes more ink to do this sign than this sign. It takes more ink to do that line than that line. However you want to do it, you're just going to memorize that. So in this case, I don't have an equal sign underneath my inequality, so I have a dotted line. So now I have completed that part of the graphing. So going back to the checklist, I've graphed the equation, I've decided on the dotted line, and now we have a very new thing, which is decide the shading of the line. And the method I'm going to show you right now is using a test point, and then we'll talk about this other method here in a moment. So we need to shade, and to shade, what you're going to do is you're going to pick any point from the coordinate grid, preferably not very close to that line, and preferably an easy point to do math. So in this case, I'm going to choose a test point of, let's go 2, 1. But I'll show you that you can use other test points as well. So 2, 1 is right here. And what I'm going to do is I'm going to take this 2, 1, which is really an x value and a y value, and I'm going to plug it into the inequality. So I've done all that. What I've done here, by the way, is I've taken my original inequality and my test point. Remember, I chose that test point just kind of on my own. I just wanted it away from the line. And I plugged the x equals 2 the y equals 1 in. And I ended up with a pretty messy example because I ended up with a fraction, but we're not afraid of fractions. You work that out all the way to just having a simplified number comparison. And it says 1 is less than 2.67. And you simply ask yourself, is that true or is that false? And in this case, 1 is less than 2.67. That's true. That means my point that I chose at random is in the true or the solution side of the equation. So I know this side of the graph is the solution side. What that means is any coordinate points that I pick from over here will make this inequality true. Anything I pick from over here will make it false. I'll show you. So choosing another test point, and in this case I'm choosing test point 6, 4. We can pretend we didn't know which side of this line to shade by the time when we chose that. So now I take my test point and I remember that that's an x value and that's a y value ever since 5th grade or 6th grade. I take a 6, I plug it in for x. I take a 4, I plug it in for y, and then I just work it out. This ends up being a -4 plus 4, which is a 0. Nothing changes when the y became a 4, it stayed a 4, it stayed a 4. And then I say, hey, is 4 really less than 0? Is that a true statement? 4 is not less than 0, so that's a false statement. That means that it's in the not a solution region. So I don't shade there. If I would have chosen that and gotten a false, I would have known to shade away from the false. So you always shade to the true, you shade away from the false, and you only need one point to do. A pro tip is, if you pick the point 0, 0, that makes for some really easy math, and I'll show you that on the next example. And by the way, a slightly less reliable way to do the shading, this is a less than sign, y is less than blah blah blah. So I'm going to shade below the line. There is definitely sometimes you can get tricked by that though, so I advocate the test point to make sure you're correct. If you're in a crunch, if that's a less than sign, you can shade beneath. Be careful with that one though. Okay, one last problem. We're going to do this one a little quicker. When I look at this problem, I notice that it's not in y equals mx plus b form. If I wanted to solve and turn it into y equals mx plus b, I could do that, but I'm going to show you or remind you of graphing by the X and Y intercepts. So keep that in mind as a good way to graph, especially when the line is in this form. So if I were going to graph this inequality by intercepts, I would set up a t-chart like this, and remember every y-intercept in the entire world has an x value of 0. Every x-intercept in the entire world has a y value of 0. By setting up a t-chart like this, I can do some pretty easy math. If x were 0, that would mean this is 5 times 0, which is 0. So I can cover that up with my finger and say, hey, what does y have to be to make negative 2y equal 10? Has to be a negative 5. If y was 0, that would mean I'm covering up this piece, and I get 5x equals 10. What does x have to be to make that work? A 2. So it's a different way to get your graph, but now I know I have the point 0, negative 5. That point is right there. The point 2, 0, right there, and I can connect these to make the graph. The next choice I have to make is, do I have a dotted or a solid line? Because this has an equal sign underneath, I know I have a solid line, so I can choose the solid graph. Then the third choice I have to make is the shading. So now if I'm going to do some shading, I have to pick any test point I want and then evaluate whether or not I have a true statement. I'd mentioned earlier that 0, 0 is a heck of a good test point. So I'm going to use this for my test point. So we'll test 0, 0, which means x is 0 and y is 0. So watch what happens when I plug that in. The wonders of a 0. You don't need to see me write this. By plugging in x equals 0 and y equals 0, I get a 0 minus a 0, which is a 0. So then I just ask myself, is this a true statement? Is 0 really less than or equal to 10? Heck yeah, it is. So I have a true test point. If I have a true test point, I want to shade to that side of the line because you're going to shade to the truth. Had I have chosen a test point from over here, I would have gotten a false. So let's just pretend I chose this one. You would have gotten a false when you worked out your numbers, and you would say, hey, I can't shade to the false side. I always have to shade away from the false and to the true. So you still would have shaded over here. It's going to work out no matter what test point you choose. And remember, if you choose any point from the shaded region, so let's just choose this point. Let's call this 1, 5. If I take x equals 1 and y equals 5 and plug it into here, it's going to be a solution, meaning when I plug them in, it's going to give me a true statement. If I take something from over here, like 6, 2, this is not the shaded region. If I plug 6, 2 into here, it's going to give me something false because this is not a solution to the inequality. The shaded region simply gives you every single x and y combination that would work in there. The not shaded region gives you every possible x and y combination that will not work in there. I'm going to give you one final look at this checklist because this is the checklist you should have down on your paper and implanted in your brain as you go through any of these problems. Graph your equation. Whatever method's going to work best for that scenario. Determine if the line is solid or dotted. That's really easy. If there's an equal sign underneath there, dotted. If there's not, if there's an equal sign underneath there, solid. If there's not, dotted. And then shade to one side of the line to represent the solution region and do it by test point. Choose an easy test point. Shade to the truth. Shade away from the false. And I mentioned that sometimes you can just look at the inequality sign and make the decision, but this one has a little bit of danger, so be careful. This one's always going to work.